Hey guys, so I'm just going to go over how to do the homework. I posted the work done out, but in case you want to see like me doing it step by step, I figured I could just make a quick video. So number one is about two ships leaving a port at the same time. Let's close this out. Number one is about two ships leaving a port at the same time. It says the first ship sails on a bearing of 40 degrees at 18 miles per hour, and the second at a bearing of 130 degrees and 26 miles per hour. How far apart will they be after 1.5 hours? Okay, so what I like to do for these is I like to do the picture first. So the first one's on a bearing of 40 degrees, the second one's on a bearing of 130 degrees. So anytime you're going to draw a bearing, you need a vertical bearing line. Then you need a spot to start making your bearings, start making your angles. So I'm going to do the first one. It says the first ship sails on a bearing of 40 degrees. Now, if you don't have a protractor, just use a straight edge and like estimate about where 40 degrees would be. Okay, so remember for a bearing, it's always the amount of the number of degrees and it's clockwise. So I'm going to set up my protractor, and it's okay if you don't have a protractor. I get it. Not everyone has one at home. It's totally fine. Just do your best to estimate. The one thing I will suggest is as you do them, like as you estimate them, and as you draw them, label it. So that way you know later like how many degrees you made that angle or you're estimating that angle to be. Okay, so that's the first bearing. The second one is 130 degrees. So again, it's coming from north and it's going 130 degrees that way. So I'm going to use my protractor. But again, if you don't have a protractor, just estimate. So 130 would be here. Okay, so rather than me labeling this whole thing as 130, I'm just going to label this one as 50, right? Because 50 and 130 are a linear pair. Then I can label this one, it ends up being 90 because 40 plus 50 is 90, and then plus 90 is 180. Then we need to make it into a triangle. It doesn't really matter how you connect them because all they gave us was this. Like if they had given us like a bearing from where this ship ended up to somewhere else, then you would need a specific spot. But just connect them. It doesn't really matter where. Now we need to label the sides. So the 40-degree one, so this one was 18 miles per hour times 1.5 hours. Let's see. So that's 27 miles. The other one is going to be 26 times 1.5, which is 39 miles. So 27 miles, 39 miles. Okay, so now it's asking how far apart will they be. So this is an example since we have a right triangle. And remember, you can only do Pythagorean theorem in SOHCAHTOA when you have a right triangle, which we do have here. You can do Pythagorean theorem or you can do trig. So I'm going to do Pythagorean theorem first. So 27 squared plus 39 squared equals x squared. 27 squared plus 39 squared is 2250. And then you're going to take the square root of both sides, which is approximately 47.43 miles apart. So that's method one. Method two would be to do an inverse trig function. So I'm just going to like slide my work underneath here so you can see how you can do a trig, use trig. So we have, I decided to find this angle here. Well, you know what? I'll just do it out. Okay, so let's say you wanted to do it with trig, which Pythagorean theorem is kind of easy for this one, so I don't know why you would want to do trig, but it's fine. So let's say like you're going to find that angle. This side is opposite that angle. This side is adjacent to that angle. So that's going to be inverse tangent 39 over 27, which is 55.3 degrees. So that means up here it's 55 0.3. Okay, then from there you could find x, the hypotenuse, by using either 39 or 27. So like, let's say you wanted to use the 39, that would be sine of 55.3 equals 39 over x. Multiply both sides by x. So then we have x times sine of 55.3 equals 39, divide by sine of 55.3. Okay, so you're going to end up getting 47.43. Okay, so that's another way you could do it. I don't care how you do it. You could do it with Pythagorean theorem or using trig. Okay, so that's number one. Number two, two cars leave an intersection at the same time. One heads due south at 55 miles per hour and the other due west. After 2 hours, the bearing from the car headed south to the car headed west is 324 degrees. All right, so we need two cars leave an intersection. So we need our vertical bearing line. We'll start here. So say here's like one of the streets. Here's the intersection. So one goes south. So the cars are here. One goes that way, one goes west. Okay, so it says the one heads south, so at 55 miles per hour, and it says after 2 hours. So let's say that after the 2 hours, this car ends up here. After 2 hours, the bearing from the car headed south to the car headed west is 324 degrees. So that means that I need to make a bearing from here 324 degrees that way. It would end up like around there. So what you're going to do is, how I like to draw these is you're going to do 360 minus 324, which is 36. So that means essentially to make this, I need a 36 degree angle that's going to go that way. So here we go. 36 degrees is about here. Oops. You want to connect it. I don't know why I didn't connect it. Okay, so this angle here is 36 degrees. This one is 324. Okay, so now here's the car that went west. So we were given that this car down here went 55 miles per hour for 2 hours. So 55 miles per hour times 2 hours is going to give you 110 miles. So this distance here from the intersection to where the car is now is 110. So it says, how far apart are they at that time? So this would be how far apart they are. And then you're just going to use SOHCAHTOA. So this is opposite. This is hypotenuse. This is adjacent. So we're going to use the 110 and the hypotenuse. So adjacent and hypotenuse, which is cosine. And the cosine of 36 equals adjacent over hypotenuse. Multiply both sides by x. So you have x times cosine of 36 equals 110. And then you're going to divide by cosine of 36. Which is 135.97 miles. So I'm going to label that in the picture as well. Okay. The next question is asking, what is the speed of the car headed west? So in order to get the speed of this car, you need to figure out how far they went in the 2 hours. So I'll do that over here. So I'm going to use opposite and adjacent now because I want to use this since it's not rounded. So it's going to be tangent of 36 equals x, or let's call it y over 110. So multiply both sides by 110. Y is equal to 110 times tangent of 36, which is about 79.92. So that's how far the car went. That's miles. So to figure out the speed, if we divide that by the 2 hours, that will give us the speed. So it's 39.9598. So I'm going to say that it's about 2 hours, about 40 miles per hour. So that's your part B. Here's your part A. Okay, so there is number 2. Okay, last one is a little more complicated. So let's take a look at number 3. So this one has kind of a lot of bearings. It gives you a bearing from Yellow Milk to Purple Foot. I like to make a list. So Yellow Milk to Purple Foot is 292 and it's 41 miles. Then we have Yellow Milk to Green Skunk is 257 in a distance of 23 miles. Final missing sides and angles. So we need to just start making our bearings. So I'm gonna make my bearing line. I like to make it in the middle of the workspace. So that way you can go either left or right with it. So here is my bearing line. I need a spot on the bearing line where Yellow Milk is going to be. So here's Yellow Milk. And now I need to draw the 2 bearings. So the 292, I'm going to do 360 minus 292, which is 68. So then that way I can just make a 68-degree angle going that way. And then remember, as you make your bearing line, or your bearings rather, you want to label the angles. Okay, so that is Purple Foot. So we'll say Purple Foot is here. Okay, the next one is 257. So 360 minus 257 is 103. So I'm going to go from the left, 103. So that's going to be about here. Now I'm making this one shorter because this one is 41 miles and this one is 23 miles. And then you can just connect them. We don't know these angles. We're going to find them. This is Green Skunk. Also, too, if this is 103, then this is 77 because those are a linear pair. And then we can add those, subtract from 180 to say that that one is 35. Okay, so notice this one is not a right triangle. Or, I mean, I guess technically we don't know if it's a right triangle yet. So we can't use SOHCAHTOA. We can't use, we can't use SOHCAHTOA. Sorry, that was my dog because they kept scraping and that was annoying. Anyway, so we can't use SOHCAHTOA, so that means we have to use law of sines or law of cosines. So we're going to find this first so here's why we're going to find that first, because we can't find one of these angles first. Some of you may be thinking that you could do law of sines, but you can't because we don't know the angle opposite the 35. Let me highlight this triangle. This is the triangle that you're focusing on. Although I guess that's probably pretty obvious right now, right? Because I didn't draw in the other bearing lines. But okay, so we're going to find this using law of cosines. So it's going to be x squared equals 41 squared plus 23 squared minus 2 times 41 times 23 times cosine of 35. Okay, so now we're going to simplify. This here is 2210, 41 squared plus 23 squared. Then we have minus 1544.92. Subtract those and you get 665.08. Take the square root and you have 25.79. And that's miles. So over here. Okay, so we have all 3 sides. Now we need to find these angles. Now that we know that this is 25.79, I can find either of these angles using law of sines because we have a side and an angle across from it, and now we have a side and, let's say, an angle across from it. We'll call that y. So now we're going to do law of sines. So that's going to be sine of y over 23 equals sine of 35 over 25.79. Cross multiply. Divide by 25.79. And then you're going to do the inverse of that, which is about 0.512. And so then you get that y is approximately 30.77 degrees. So I'm going to fill that in. Okay, so now if we subtract 35 and 30.77 from 180, so 35 plus 30.77, and then subtract from 180, we're going to get that this one is 114.23. Okay, so those are all the angles and sides. I did ask you to do an extension I hope you tried it, but find the bearing from green skunk to purple foot. I realized that I didn't do any examples like this in the notes where you had to find the bearing, but here we go. Here's how you find a bearing. So I'm going to put a vertical bearing line through green skunk and purple foot, keeping in mind that they have to be parallel to the one that I had for yellow milk. Okay, so basically the bearing from green skunk to purple foot is going to be from this north bearing line all the way over here. The bearing from purple foot to green skunk is going to be from the north bearing line to here, because that's the line that takes you to green skunk. Okay, so let's think about what we could find here. I'm just going to fill in as many angles as possible. Like, for example, this angle right here is alternate interior to this one. So it's 77 degrees. So you want to make sure you use things like alternate interior angles. So that's just, let me zoom in on this so you can see it better. That's just this angle. It's alternate interior to this one. So now if this whole thing is 114.23, I can do 114.23 minus 77 and get 37.23. So this little one here is 37.23. Okay, so that is actually helpful. That's helpful because, oh, actually, you can do this in an even easier way. I just thought of something. So there's a few ways you can find this angle up here. So wait a second. Sorry, I'm all over the place. So to get this bearing from here all the way to here, we really just needed to find out what this piece was. So now we can subtract that from 360. So we can do 360 minus 37.23, which is 322.77. So that's the bearing from green skunk to purple foot is 322.77. So now we need this portion to find purple foot, and we can add that to 30.77. So I don't know if you guys noticed that this and this are consecutive interior, but this would be 112 because 180 minus 68 is 112. Another way you could do it is this is 37.23, which is alternate interior to this one, 37.23. So then you could subtract 37.23 from 180 to get the whole thing. So which is essentially going to be 112 plus 30.77. So 180 minus 37.23 is this whole piece from here all the way to here. So it's these two together, which is 142.77. So that's the bearing from purple foot to green skunk. 142.77. Okay, so you really just have to use what you know and find all the angles that you can possibly find, and that's how you can find bearings. All right, so that's number 3. Take a look at the video for today on the second method of bearings, and if you still have questions about this homework assignment or the one for today, feel free to join our Zoom at 1, or you can email me. All right, have a good day.